All right, we're now going to move on to the second section of Chapter 11. And so I'm going to go ahead and introduce the material. And then on the back side, there'll be some example problems for us to practice on. So on the front side here, it starts out nice and easy, gives you some definitions. A central angle is basically an angle that is whose vertex is at the center of the circle. So that would be a central angle right here. And of course, a semicircle is where you have a diameter, and so half of the circle would be a semicircle. And if I go over here and draw that central angle in again, where the center of the circle is the vertex, this, the inside part of it, is what we call the minor arc. And the back side, which we generally don't refer to when we're talking about the angle, but the back side of it, when we're talking about a central angle, but the back side of it has an arc here that is called the major arc. Generally speaking, the measure of the minor arc is going to be less than 180 degrees, whereas the measure of the major arc is going to be greater than 180 degrees. And semicircle, of course, has a measure of 180 degrees. And the one thing about all this stuff, and it'll make more sense when we get to the backside, and that is to keep in mind that the measure of the arc that we're talking about here is not the same as the length of the arc. The length of the arc, if you remember, is when I go ahead and grab these two endpoints, grab this arc here, and then place it down, stretch it out so that it's straight, and I measure it. That's the length of the arc. And the measure of the arc, of course, is whatever the measure of the central angle is the same as the measure of the arc. And then the next piece of information for this section is this idea that if I have two central angles of a circle that are congruent to each other, so if these central angles here are congruent to each other, and I take the endpoints of the central angles and join them with the segment and create chords, that those two chords of the circle are congruent to each other. So if the central angles are congruent, then the chords are congruent. And if the chords are congruent, then I know that the arcs that join the endpoints of the chords are congruent to each other. And additionally, I know that if I draw in these segments that measure the distance of the chords from the center, I know that those distances are also congruent to each other. And these are all interchangeable. So if I know that the two central angles of a circle are congruent, and I take a look at the two arcs that those central angles cut off, the intercept, I know that those two arcs are going to be congruent to each other. And so all these things are interchangeable. All four of these things, these ideas, are interchangeable within the same circle or within congruent circles. All right, that's it for the information. We'll now flip over to the next page and so on the next page, we have some nice little example problems. The first example problem here is on the easier side, and then the next three are a little bit tougher. The first one here, we're talking about concentric circles, so circles that share the same center. And the center of the circle is going to be at O here. And so angle BOD is 60 degrees. That's the central angle. And we know that AB and AO are congruent to each other. They're both 5. And so, of course, the radius of the smaller circle is 5 and the bigger circle is 10. And I'm supposed to find the measure of arc AC. So I'm not sure what happened with my symbol here, but that's the measure of arc AC. The measure of the arc, of course, is the same as the measure of the central angle. So I know that this arc has a measure of 60. And the measure of this arc, which is over here, interestingly enough, has the same measure. It's 60 degrees because it shares the same central angle. But if we take a look at the length of the arcs, and we remember from earlier section, the measure of the arc divided by 360 times the circumference gives you the length of the arc. It's the fraction of the circumference is going to be the length of arc AC. And so in this case here, the measure of the arc is 60 divided by 360, or 1/6 of the circumference. And the circumference, in this case, the radius for AC is going to be 5. So 2 pi r, or it's going to be 10 pi. And that'll simplify ultimately to 10 pi over 6, or 5 pi over 3. Whereas the length of arc BD, hopefully you all can see that this length here, this length of this arc, is going to be a lot bigger than the length of the arc from A to C. And so if we check this out, the measure of the arc is the same, so it's 60 over 360. But the circumference is going to be a lot bigger for the bigger circle. And in this case, it's going to be 2 pi r, or it's going to be 20 pi, because the radius is 10. And so this ends up being 20 pi over 6, which simplifies to 10 pi over 3. So if you look at this, the two lengths of the arcs are very different. And then the measure of BFD, whenever I use, again, sorry about the symbol there, whenever I use the 3 letters, I'm going to be talking about the major arc. And the major arc, remember, is going to be the back side of this. So it's going to be B, then F, and then over to D. And so in that case, I know what the measure of the minor arc is 60, and I know that the entire circle has a measure of 360, so that this has to have a measure of 300 for the major arc. All right, moving on to some example problems here. And I went ahead and moved some of the diagrams over. So this is the center of the circle X. XM is perpendicular, so I got a right angle here and here. I know those are the distances to the chords. ABC is isosceles with a base BC, so I know that the chords AB and AC are equal to each other, or are congruent to each other. So I'm given some information here, and what I'm looking for is the area of the circle. So ultimately here, what I need is, I need the radius to get that area of the circle. So I'm going to work towards it. I know that this distance is the same as this distance, so I know that 7x minus 12 is equal to 3x plus 6. And if I solve this thing, I'm going to get x is equal to 9/2. I'm going to check my work on that. And then when I plug it back in, I get that mx is, just plug that guy back in, 7 times 9/2 or 4.5 minus 12. So that means that my mx is 19.5. I also know that if I take this x value and plug it in here, I can find AB, and AB ends up being equal to 8 times 9/2 plus 2, and that's going to be equal to, I think, 38. So I know that this whole chord here is 38, so I know that this is going to be half of that from the last section. The information from the last section will be 19. I know that mx is 19.5, and I can do Pythagorean theorem right here. There's my hypotenuse. I can solve this little triangle here, and so doing Pythagorean theorem, I can get that XA is equal to 27.23. So I'm going to go ahead and do that work on the side and get 27.23. Once I know that the area of the circle is just equal to pi r squared. And so pi times 27.23 squared, since that's my radius, XA, ends up being equal to some big number, 2328.71. Okay, a lot of work there, but all that hopefully makes sense to you. Next problem here, you're given an isosceles trapezoid trap. And I know that TP is 8x plus 3, so that's the measure of the arc there. I know the measure of RT is 150. I know that ART, this angle here is 12x plus 117. And oh, actually that thing is an arc, so it's not an angle measure. Sorry about that. So I know that this actually is going to be the measure of this arc all the way from here to here. Okay, so that makes more sense now. I know that in an isosceles trapezoid, this angle, or this leg and this leg, are congruent to each other, which means that this arc here from T to P is congruent to the arc from P to A, or R to A. And so that means that this arc right here is also 8x plus 3. They're congruent to each other. And so I can use I can set up a little equation here. I know that 12x plus 117 is equal to 150 plus 8x plus 3. So I know that this all the way from here to here is 12x plus 117. I know that this is 150. I know this is 8x plus 3. I can add those together and set it equal to the entire measure of the arc. When I solve that, I get x is equal to 9. And then, so that gives me a lot of information here. When I plug stuff back in, I know that, for example, TP ends up being equal to 75. I know that this also is going to be 75. I know that RA is 75. And what I need is, I guess what I'm looking for here is I'm looking for this guy, PAR. So I'm looking for the arc all the way from here to there. And so the piece I'm missing is this piece down here. I'm missing PA. And so PA I can find from taking 360 and subtracting all the measures of the arc up above. So subtracting this guy and this guy and this guy to get PA. So minus 75, minus 150, minus 75. So PA ends up being equal to 60 degrees. And then now to find PAR, it's just going to be 60 plus 75, or I believe 135 degrees. Okay. Let's move on to the last problem here. I'm given circle X, so this is the center of the circle again. BXA is congruent to CXD, so I know that these guys up here, these two arcs, are congruent to each other also. XBC is 72. Keep in mind that this is an isosceles triangle here, because those are both radii, so this is also 72 here, which means that this angle right in this central angle here is 36. So that means that the arc measure is also 36 degrees. Now I know that because this is a semicircle right here, I don't know if this is a semicircle, I know that the measure of that thing is 180 degrees. So 180 degrees is equal to, let's call this x, and let's call this x, 2x plus 36. And when I solve for x here, x ends up being equal to 72. Because half of 144 is 72. And once I find that, I'm looking for the measure of arc CDA. So I'm looking for the measure of this arc right here. Here all the way over to there. I know that x here is 72, and I know, of course, that this is a semicircle, so this is 180. So the measure of this is equal to 180 plus 72, or it's equal to 252 degrees. Okay, hopefully that backside made sense. I know these last three problems were a little on the tougher side, especially the first one, problem number 1 there, is pretty tough. But hopefully that did make sense, and go ahead and give the problems in the assignment a try. All right, take care.